Hello everyone, welcome to revision questions in integral calculus. I'll be using method of substitution to do my integrations. You can see that I've been given evaluate the following, giving your answer to 3 decimal places. A, B, C, they are all definite integrals. So I want to use the substitution method to do this. Although we have other methods, we have integration by parts, and we have several other methods one could use to get the same solutions. So let's go straight to the first question. And the first question is integral of x multiplied by square root of 1 plus 2x dx, and our limits are from 4 to 0. So for us to use substitution method, we'll say let u be 1 plus 2x, and then differentiate this to give us du equals to 2 dx, or we can say that dx equals du over 2. So we substitute this in our equation here, but remember that our integral that we're given from 0 to 4 to 0 can be written as x multiplied by 1 plus 2x raised to a half dx. So when we substitute this dx, when we substitute this dx inside here, what we would now have would be the integral from 4 to 0 of x. Instead of this is what we call u, 1 plus 2x, we call it u. So it will be u raised to a half. But dx, our dx here is du over 2. Du over 2. Now doing this will give us the integral from 4 to 0 . Yeah, we can see we have an x here, we have an x. So since we are using substitution, we need to get rid of x so that we only have u. So what that means is that we go back to this equation, go back to this, and make x the subject of the formula. So what this means is that if I was to make x the subject of the formula here, I would have x being equal to u minus 1 over 2. Remember that every time you are substituting, you're using substitution method, you must get rid of x. So if you've chosen to write x in terms of u, everything must be in terms of u. So let's now just do that. Let's now write where there is x, right, its equivalent in terms of u. So this will be the integral from 4 to 0. So instead of x, you're writing u minus 1 over 2, u minus 1 over 2. Then there is u raised to a half, and then we have du over 2, du over 2. At this point, we would take all the constants outside the integral, outside this integral sign, and our constant is 1 over 4. The integral from 4 to 0 of u minus 1 multiplied by u raised to a half du. So let's just expand our bracket here. So what we would have would be 1 over 4, the integral from 4 to 0 of u raised to 3 over 2 minus u raised to half du. So we can now integrate. We have everything in terms of u. So we have 1 over 4 into, integrating this, remember that we add 1 to the power and divide by the new power. So if I were to add 1 to this power, I would have 5 over 2. So what I'm writing is now u raised to 5 over 2. And remember that when you're integrating, you divide by the new power. So when I divide this by 5 over 2, I would have 2 over 5 there. And then again add 1 to this, you get 3 over 2. So you have u raised to 3 over 2. And divide this by the new power. Our new power is 3 over 2. So dividing this by 3 over 2, I would have 2 over 3 here. Since these are definite integrals, there's no need of adding constant of integration. So I'll just remember that I'm integrating from 4 to 0. Remember that these 4 to 0 were limits for x values. So you may want to change the limits, but I've decided not to change the limits. I want to still work with my limits 4 to 0. So that means I should replace u with its equivalent. The equivalent of u was here. It was 1 plus 2x. It was 1 plus 2x. You can see it here. That was our u, 1 plus 2x. So while there is u in this equation, we'll be writing 1 plus 2x. So let's just do that. So this becomes 1 over 4 into 2 over 5, 1 plus 2x raised to 5 over 2 minus 2 over 3, 1 plus 2x raised to 3 over 2, and our limits are 4 to 0. So we just put our upper limits, then minus, again put our lower limits. So let's put our upper limits. Remember that this 1 over 4 is outside, so it's 1 over 4 into 2 over 5. Putting the upper limit to 0, this will be 1 plus 2 multiplied by 0, which is just 1. 1 raised to 5 over 2 would be 1. So what I have there is 1. Then minus 2 over 3 into 1 plus, this is 2 times 0, which will be 0, plus 1 will be 1. 1 raised to 3 over 2 will just be 1. Close the bracket, then minus a quarter. This time we replace our lower limit. So 2 over 5 into 1 plus 2 multiplied by 4. 2 multiplied by 4 is 8. 8 plus 1 would be 9. 9 raised to 5 over 2. Then minus 2 over 3. Again, this is 9 raised to 3 over 2. Close the bracket. So at this point you could even use your calculator here. You could use your calculator, or let's just do it. This will be 1 over 4 into, our LCM here is 15, and this will be 5 will be going there 3, so this is 6 minus 3 is going into 15, 3 goes into 15 5 times, so this will be 10. So 5 went into 15 3 times. 3 times 2 gave us 6. Then minus 3 goes into 15 5 times. 5 times that would be 10. Then minus a quarter. Let's again simplify this. This is the same as 3 square. 3 square raised to this. The same as 3 raised to 5. So 2 over 5 times 3 raised to 5, because this is 3 square, so what you have is 3 square raised to 5 over 2, that would be 3 raised to 5. And then minus 2 over 3, again this is 3 square raised to that, the same as 3 raised to 3. 3 raised to 3. Close the bracket. So let's use our calculator here. And when you use your calculator, what is this? This is, in fact, this is a quarter. This is a quarter times, this is negative 4 over 15, and then minus a quarter into what is 3 raised to 5. So this is a calculator. Find 3 raised to 5. 3 raised to 5 would be 243, then multiplied by 2 and divided by 5, then minus 27 times 2 divided by 3. So what I'm getting here would be getting 79.2. 79.2. So again, using our calculator, that would be 1 over 15. 1 over 15, remember it's negative. It's negative 1 divided by 15, and then minus 79.2 divided by 4, and you get the answer from the calculator will be negative 19.86666667. But the question wanted us to do it to 3 decimal places, so we would have negative 19.867 as our answer. So that is our part A. Let's see what part B required us to do, and then do it. Part B was the integral, so you can just do it somewhere here. You can just do it somewhere here. Let me do it here because I can see. So part B requires to do the integral of sine raised to 3 of z cos z dz from 0 to pi over 3. Now at this point it's good for us to look at the exponents. The power of sine here is 3 and that of cos is 1, so the powers are both odd. So if since they are both odd, it's easier for us to get rid of the one that has a lower exponent, the one that has a lower power. It's cos. Cos has 1, the power is 1, and sine has power of 3, so it's easier for us to get rid of cos. So for us to get rid of cos, we would say let u be sine z. So if u is sine z, differentiating this would give us du equals to cos z dz, or that dz equals to du over cos z. So we substitute this in our integral there. Let's do that. So we'd have the integral from 0 to pi over 3 of, this is sine raised to 3, sine raised, but our sine was u, so we're talking of u raised to 3 cos z, but dz is du over cos z, du over cos z. So at this point you can see that cos z will cancel, so what we will be left with will be the integral of u raised to 3 du from 0 to pi over 3. So we can now integrate this, and as we said, we add 1 to the power to get u raised to 4, then divide by the new power. Since it's a definite integral, it's needless writing the constant of integration, so there's no need of adding constant of integration. Let's just recall that we are doing this from 0 to pi over 3. Now remember that 0 to pi over 3 were the limits for z. Sine, that was z, not u. It was, so that means you must substitute. Get rid of u now. Get rid of u. So instead of u writing sine z, so what we have here will be sine raised to 4 of z over 4 from 0 to pi over 3. Remember this is just the same as sine of z raised to 4 over 4 from 0 to pi over 3. So we use our calculator to find sine of pi over 3 and then sine of 0 and subtract the 2. So sine of pi over 3, we raise it to 4. We raise it to 4. And then divide by 4. And what I'm getting is 0.140625, then minus Sine of 0, you can just use your calculator, but if you know them offhand, there's no problem. Sine of 0 will be 0. So that means that our answer remains to be 0.1406, since we are told to do it to 3 decimal places. Now we go to the last question. Let's do the last question. The last question wanted us to integrate 1 over x ln of x dz. It's supposed to be dx. Supposed to be dx. And our limits are e to e raised to 2. So let's try and do it. Let's do it here. Let's see. The question was the integral of 1 over x ln of x dx from e to e raised to 2. Again, we are doing this using substitution, so I would just say let u be ln of x, and when you differentiate this, you get du to be 1 over x dx, or that dx is x du. So let's substitute that. So our integral now becomes 1 over, there is an x, but instead of ln of x, we said that would be u, and instead of dx, we said that dx would be x du. So you can see that x will cancel, and so what we are left with will be the integral from e to e raised to 2 of 1 over u du, which is ln of u. No need of adding constant of integration because this is a definite integral. Let's just recall that we are doing this from e to e raised to 2. So we just put our limits. Let's put our limits now. So what do we have? What we have now will be, instead of u, we know that our u was ln of x. Ln of x from e to e raised to 2. Now putting our upper limit, what we would have would be ln of instead of x we have e raised to 2, and then minus. Now put the lower limit, would have ln, instead of x we have e raised to 1. Using our laws of logarithm, this is 2. This will be 2, because this will be 2. So what we have here will be ln of 2 minus, and again using the laws of logarithm, this will be 1. So we have ln of 1. So at this point you can just use your calculator. We have ln of 2 minus ln of 1, and that gives you 0.6934. 1 4 7 and so on, but the answer is required to 3 decimal places, so I would write 0.693 as the answer. So next time we look at applications of this integration, and again we'll look at other examples and then look at examples in applications.